right, so looking at this first problem, the one you started on your own, the first thing you always want to look at when you're graphing these is if you have a shift left or right. So what does that minus pi over 2 do? It takes us to the right pi over 2. So that's where we're going to be starting our x's, is at pi over 2. The next thing we want to look at is right here. That's going to result in a change in the period. So for these problems, normally the period's 2 pi, but in this case, we're going to have to do 2 pi divided by b, which is 1/2. And so what is 2 pi divided by 1/2? 4 pi. If I take that period and I divide it by 4, that's going to tell us how much to add on every time. So if I added on a pi, that's going to be 1.5 pi, 2.5 pi, 3.5 pi, and 4.5 pi. And then I had to think of what my normal sign values are. And these normally go 0, 1, 0, -1, 0. That just came from the unit circle. The next thing we always have to do is order of operations. So we would multiply by this. So we have to multiply by -3. And the last thing we do is we shift up or down. So we're going to shift up 2. And so those should be our key points. And so then you should have gone to pi over 2, you're at 2. 3 pi over 2, you're at -1. 2.5 pi, you're at 2. 3.5 pi, you're at 5. And at 4.5 pi, you're back to 2 again. And so that's what you should have had for your answer. Remember that we can also check these. So if you're taking a quiz and you're just feeling a little, stressed out maybe the quiz is kind of long and you feel like you don't have time, you're not sure you did it right, well then you just want to come in here, put in your curve, -3 sine 1/2 parentheses x minus pi over 2. I need double parentheses to close that out. So you have to have this in parentheses as well. That's something people don't realize, because it's got to be the sign of this whole thing. And then at the very end, plus 2. So what I'm going to do is I'm going to set up my table. By my table set, I'm going to set it up to look like mine. So my table starts at pi over 2, and the change in my table, I went up by pi every time. And so now when I look back at my table, I should see my key points. 2, -1, 2, 5, 2. We're good? All right. Questions on that? Okay. So now we're going to talk about how to graph tangent and secant. You can use a graphing calculator, but I kind of want you to understand why they look the way that they do. So for the tangent graph, I'm going to think at -pi over 2. This point right here would be 0, -1. So if I'm trying to find the tangent, tangent's going to be y over x. What's -1 over 0? Undefined. So this is undefined. At -pi over 4, that's right here. Do you guys know the tangent of 45 degrees? 1. And if I'm down here, what's it going to be? Not 1, but -1. And 0, right here, this is the point 1, 0. Tangent, y over x is 0. Pi over 4, that's going to be +1. Pi over 2 is going to be undefined again. So here, these are going to be vertical asymptotes anywhere we have undefined. So at -pi over 2, we're undefined. Pi over 2, undefined. Any odd multiple, so we're going to have vertical asymptotes at odd multiples of pi over 2. 2 pi over 2 reduces to pi. That is not an odd multiple of pi over 2. But 1 pi over 2, 3 pi over 2, 5 pi over 2. So now I'm going to put in my points. At -pi over 4, I'm at -1. Here I'm at 0. Here I'm at 1. And this curve just goes like this through those points. -1, 0, 1. And we just could continue that pattern indefinitely because it's a periodic function. If we go to y equals, I can put this into my calculator, just tan x, clear all the rest of it out. Do a zoom trig again. And it shows me that this is the way it looks. The tangent function is always increasing from left to right. See how it's from here to here it's going up? So the tangent function is always increasing. Now, if I want to graph secant, secant is the reciprocal of cosine. So I'm going to think of cosine theta first. So if I do the cosine of 0, thinking of my unit circle again, right there, the cosine of 0 is going to be x over r, so that's 1. Pi over 2, I know these key points, 1, 0, negative 1, 0, 1, 0, negative 1. But secant is the reciprocal of those. So this is the reciprocal of 0 is undefined. This is undefined. This is undefined. So again, I'm going to get vertical asymptotes at the odd multiples of pi over 2. So at negative pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2. That's where all of our vertical asymptotes are going to be. Then I know the points go 1, and then here I'm undefined. Here we're at negative 1. That's 1. At 3 pi we're at negative 1. But maybe it doesn't really make sense what to do with it now. If you think of the cosine curve, I'm going to put the cosine curve in here really lightly, because I'm not really graphing cosine. But secant is the reciprocal. So think of this. The reciprocal of 1 is just 1. This value is 1/2. The reciprocal of 1/2 is 2. This value is 1/10. The reciprocal of 1/10 is 10. So you should be able to see why the function is going to look like this. The reciprocal of negative 1 is negative 1. This value right here is about, right here rather, on the curve right here would be negative 1/2. That reciprocal is negative 2. It looks like these almost look like parabolas, but they're really not. Now, if I wanted to check this, I could check this pretty easily by going into y equals. I'm going to graph cosine just so you can see the relationship. To graph secant, I would graph 1 divided by cosine. And let's see, we graphed it from like negative pi to 4 pi. So I'm going to change my window to go from negative pi to 4 pi, just to make it look exactly the same. And now I'm going to hit graph. Here's my cosine curve, and here comes my secant curve. I made my secant go in bold. Does that make sense? Any questions? All right. You're going to be allowed to use your graphing calculator, but I kind of want you to understand where it all comes from as well. For cosecant, what do you think I could graph as a helper to graph it? Sine, yeah. Sine goes 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. And wherever I have 0, I'm going to get a vertical asymptote. So here's a vertical asymptote. So these vertical asymptotes are occurring at multiples of pi. And I'm going to go down, up. So see, you don't have to have a graphing calculator to graph these. You should have a pretty good idea of what they look like without having to graph sine and cosine and without having to use your graphing calculator. For cotangent, again, I can think of that unit circle. This point right here was 1, 0, 0, 1, negative 1, 0, 0, negative 1. To graph cotangent, it's going to be x over y. So 1 over 0 is undefined. Right here at pi over 2, cotangent, x over y, that answer is 0. At pi, my answer would be undefined again. 3 pi over 2, x over y would be 0.